Hello, this is Mr. Wright. This is the One-Step Equations Addition and Subtraction video. We will be using MSG pages 95 and 97. First, open your MSG to page 97. An equation. An equation is a mathematical sequence containing an equal sign, showing that two expressions are equivalent. So unlike expressions, equations contain an equal sign. An inverse operation. Opposite operations that undo each other. For example, the inverse operation of addition is subtraction. The inverse operation of subtraction is addition. So if we add something and we want to do the inverse operation, we will subtract something. If we're subtracting something, the inverse operation to undo it is addition, and you will see how important inverse operations are in solving equations in just a few moments. Now open your MSG to page 95. Please fill in the blanks at the top of your page. When solving an equation, you must first determine the inverse operation. Then apply the inverse operation to both sides of the equation. This is to keep it balanced, to keep it equivalent. Lastly, you should always substitute your solution back into the equation to check your work, to make sure it balances. So for example, now turn back to page 97. For example, if we have the variable m plus 8 equals 10. Okay, first thing, I'm going to do something that's called drawing a line in the sand. We're going to draw a line in the sand. This shows both sides of my equal sign. Okay? And now here I have addition. I want to solve for my variable m. I want to find the value of m. Okay? So first, I'm going to have to undo the operation of addition. So, to undo, I'm going to subtract 8 from both sides by applying the inverse operation. The goal is to get the variable by itself on one side. When I get the variable by itself on one side, that means that the m or the variable is equivalent to the value of the other side. In this case, m, once I get m by itself, it will be equivalent to whatever is on the right side of the equal sign, because they will be balanced, hence the definition of equals. So if I subtract 8 from both sides, 8 minus 8 is 0. So it goes away. Okay? It cancels out, as we would say. 10 minus 8 is 2. Okay? And then I bring down the m. Okay? So I have m by itself on the left and 2 by itself on the right. So m is equivalent or equal to 2. Now I need to go back and substitute 2 in for m, like we did in Unit 3. 2 plus 8 is equal to 10. Okay, let's simplify. 2 plus 8 is 10, and 10 is equal to 10. Check! Yay, it is equivalent. Yes, we are good to go. So m must be 2. Okay. Now let's try this example. Again, where the equal sign is, I'm going to draw my line in the sand. Okay? And I want to get the variable k by itself on the right side. So I'm going to undo subtraction. So to undo subtraction, I'm going to add 3 to both sides, because the inverse operation of subtraction is addition. Okay, when I add 3 to this side, it goes away, because adding 3 to minus 3 gives me 0. 3 plus 17 is 20. Bring down the variable by itself, bring down what's left, and as we can see, k and 20 are equivalent. So k equals 20. Now, am I done? Am I sure that's the correct answer? Well, no. I must go back and substitute in 20 for k to check it if it's the correct answer. 20 minus 3 is 17. Therefore, 17 is equivalent to 17. Yay! That is correct. We are successful. So k must be equivalent to 20. Okay, now go back to page 95. In your little 4-column or 4-square chart that you have, in the one column with the plus sign, write this example problem and let's solve it. Okay? So again, I'm going to draw my line in the sand. Drawing my line in the sand. Okay? And I want to get C. I'm going to solve for C. So I want to get C by itself on the right. To do that, I'm going to have to undo the operation of addition by subtracting 38 and 6/100ths from both sides. Whatever I do on one side of the equal sign, I have to do on the other, again, to keep it balanced. Okay, so 74.2, or 74 and 2/10 minus 38 and 6/100ths. Okay, remember you cannot use a calculator. Okay, this side cancels out to 0, or simplifies to 0. You bring down the C. Okay. And let's see, we're going to have to line up my decimals. So remember reviewing, subtracting your decimals. Line up your decimals. I got to borrow 1 from this 2. Okay. Which will give me 10. Because remember, we put zeros in as placeholders. 10 minus 6 is 4. Okay. I got to borrow from this 4. Give me 3. That'll give me 11. 11 minus 0 is 11. Oh, whoops. Let me fix that. I didn't see that was a 0, so actually I do not have to borrow from that one. So let's try that again. Okay. 10 minus 6 is 4. 1 minus 0 is 1. Bring down your decimal. I need to borrow 1 from the 7. The one here. 14 minus 8 is 6. And 6 minus 3 is 3. So therefore C must be equivalent to 36 and 14/100ths. Well, I say must be, but we have to check our answer, of course. So then 74 and 2/10 is equivalent to, substitute for C, 36 and 14/100ths. Plus 38 and 6/100ths. Okay, so we're going to add 36 and 14/100ths plus 38 and 6/100ths. Okay, remember, line up your decimals. Okay, 6 plus 4 is 10. Carry the 1. 1 plus 1 is 2. Bring down your decimal. 6 plus 8 is 14. Carry the 1. 3 plus 3 is 6. Plus the 1 is 7. That is 74 and 2/100ths. Yay! They are equivalent. 74 and 2/100ths is equivalent. Yay! So therefore, C must be equivalent to 36 and 14/100ths. Okay, now put this example in the subtraction part of your of page 95. Okay. Now, when working with mixed numbers, we need to change the mixed numbers to improper fractions. So let's rewrite this as x minus, okay, 4 times 4. 4 times 4 is 16 plus 3. So 4 times 4 is 16 plus 3, which is 19, over 4, is equal to 1 times 2 is 2, plus the 1 is 3 over 2. Okay, now draw the line in the sand. Draw the line in the sand. And now we're going to undo the operation of subtraction, so we can get x by itself by adding 19/4 to both sides. Of course, this simplifies to 0. We're left with x on the left is equal to, or equivalent to, 3 over 2 plus 19 over 4. Okay? So 3 over 2 plus 19 over 4. Okay? First, we got to find, when adding fractions, this should be kind of a review, we need to find common denominators. So 2 times 2, and the numerator times 2. Whatever we do to the bottom, we do to the top. So 2 times 2 is 4. And 3 times 2 is 6. Plus 19 over 4. Okay, so now we just add the numerators. 19 plus 6 is 25 fourths. Okay, and let's change 25 fourths back to a mixed number. So 25 divided by 4. 4 goes into 25 6 times, which is 24, with 1 left over, so it's 1 out of 4. Okay, so 6 is equivalent to 6 and 1/4. Now, just like before, we can't say we're done. We have to substitute our answers. So 6 and 1/4 minus 4 and 3/4 is equal to 1 1/2. Okay, well, to check that answer, we got to change these to mixed numbers. 6 times 4 is 24 plus 1 is 25 over 4 minus 19 over 4. When we change 4 and 3/4 into an improper fraction, and we're going to leave this as a mixed number because we'll see at the end. Okay, 25 minus 19 is, okay, that will be 6 over 4 equals 1 1/2. If we change 6 and 1/4 to a mixed number, we get 1 and 2 over 4, which simplifies to 1 and 1/2, which is equivalent to 1 and 1/2. Check! Yay, they are equivalent. Okay? So then x must be equivalent to 6 and 1/4. Okay? When we are adding, subtracting, multiplying, dividing with decimals and fractions and mixed numbers, these are all items that you have learned before, so we're going to continue to work to improve on these areas that you need to work on. Okay, so now in class we are going to do the problems on page 97 for classwork. Thank you for watching the video.